Hello there and welcome back. In the previous video I have shown you how you can utilize the Asyncio module to provide this cooperative multitasking in a single thread to your script. And in this video I have shown you how you can calculate the highest Fibonacci number below a specified x value. And I have done some investigation and I thought I would show you how you can write something that is related to the performance testing of these async IO versions of the algorithm. So basically I'm going to show you how you can implement some kind of testing, in a sense that if you have a generic problem where you can define multiple functions to achieve the same solution to that problem, then you should be able to benchmark it based on the time it takes, for example, to execute those functions. And I have found 2, 3, 4 different versions for the Fibonacci algorithm, and I'm going to show you how you can implement them in Python and how you can measure the time it takes for each individual function to calculate the specific value of x. So let's get to it. And no, don't. I'm going to create a new file. Async Fibonacci speed test.py, and we will need the async IO module. We will need the time function from the time module. We will also need the square root function from the mass module, and we have the algorithm from the previous video, which goes like this. This is the simple recursive version that was used to demonstrate the speed. Also, there is a version which is called Fibonacci recursive with memoization, which uses a dictionary to store each value based on the Fibonacci number and update it if necessary. So we say that if n is not in m, then n equals to Fibo recursive memoization n minus 1 plus Fibo n minus 2, and in the end we will return the m. So this is also another recursive version for the Fibonacci, and we have this Lucas version. And this goes like this. We have to calculate the phi, which is the 1 plus square root of 5 divided by 2. And we will return the integer version or type enforced value of the phi power to the n minus phi to the power of minus n divided by square root of 5. I have never seen this algorithm, but I thought it would be fun to see the performance this shows. And we will have the Fibo iterative, which is the algorithm that is taught in, let's say, school, that we have an I and the j value. The I goes for 0, the j is getting assigned 1, and we go over the range of 1 and plus 1. Let me do this, and I and j equal to j and I plus j. This is really cool stuff in Python, because you don't have to assign a temporary variable like Pascal or C, but you can swap the values. And in the end we will return j. And here comes the fun part. So we had in the previous video the async definition of the highest fibonacci below, and we gave it an x value, but now we want to give it a function that is going to be used to calculate this value. And we will print with f string the highest fibonacci below x from function. And if you don't call the function, you just specify the name of the function, you can refer to its name with the underscore name. So this will print, in this case, Fibo iterative, Fibo Lucas, Fibo recursive memoization, and Fibo recursive. So basically this is a very convenient way to say that you want the name of the function that is passed here as an argument. And as always, the t0 is time, and we will iterate over the range of x and say that temp equals to function y, and if the temp is greater than x, then we will call the function again for the y minus 1. And after this, we will return the temp, and we had this await async IO steep 0.0.5, 0.5, and here we want to print some immediate results, the highest Fibonacci number below the given x is the temp, which is from the function the underscore name, and the duration was from point to f milliseconds. And here we need to print the x, the temp, function underscore name, and 1000 times t0 minus time. Yeah, let's save it. And here we have another change in the get results. So async def get results. We will have the t0, which is time, and await async wait, and this is going to be really ugly, but it will only take one line. So the highest Fibonacci below, number is the number, and the function is the function which will be passed, and for number in an array which is going to consist of, let me copy the prepared statement here, So where are we? Yeah, and for function in, here is also an array, and this array is going to hold fibo iterative, fibo Lucas, fibo recursive memorization. So here you have all four functions. And in the end, we would like to print that this all took me 0.2f milliseconds. So 1000 times t0 this time. And as usual, we will need to have this if the underscore name equals main. The loop is going to be async IO get event loop, and the loop run until complete get results, and loop close. Alright though, so basically we have defined these four functions, and we have modified this highest Fibonacci below function, so it eats an argument, which is a function. So this is going to be substituted with the actual function that is passed here, and the async wait is going to have now an array with four functions, and each function is going to be called with each number defined once. And let's do this. So I have enlarged the terminal, so Python async Fibonacci speed test. Seems like there is something wrong here. So we have this highest Fibonacci below. Here we have one for loop. And here we have another for loop. Cool, really cool. But I should swap these two as minus t0, and here also minus t0. Go, go, go! So we don't have these negative values, and clear. Let's do this. As you can see, here we get the message that we will calculate the highest Fibonacci number below 10,000, 20,000, and so on. And the results are popping up in the incremental order in which the numbers are getting larger and larger. It takes more and more time for these functions to calculate it. So basically, what we can say here is that if we take this 3 million value, we can see the, let's mark it, we have one result, which is the memoization version. This takes 7 seconds. We have the iterative version, which takes 11 seconds. We have the Lucas version, which is also 11 seconds. And we have the recursive version, which is 21 seconds. So apparently, this memoization version is a lot faster than the recursive version I have shown you in the previous video. But basically, this is a generic way to do some speed testing on your async version of functions. And I hope you liked this video, and if you did, give it a thumbs up and subscribe for more. Thank you for watching.